Good morning, one and all. My name is V. Abhijit Kumar. My roll number is 24951A6602. I am studying in CSC AIML, that is Computer Science and Engineering, with a specification of Artificial Intelligence and Machine Learning, second semester, Institute of Aeronautical Engineering. In this video of a tech talk of the subject of Applied Physics, I am going to discuss about the topic orientation sensitivity of a hexagonal lattice photonic crystal fiber. In this presentation, I am going to give an overview of how orientation affects the optical properties of a hexagonal lattice and its PCFs. In this topic of orientation sensitivity of hexagonal lattice photonic crystal fibers. First of all, I would like to go through the contents which I am going to discuss about in this presentation of mine. In the first place, I am going to introduce the concept to you, and I am going to explain about the concept of photonic crystal fibers, that is PCFs. And after that, I am going to discuss about the concept of hexagonal lattice PCFs, their structures and their properties. And after that, I would like to discuss about fundamentals of orientation sensitivity. And after that, I'll discuss about mode propagation in hexagonal PCFs. And after that, I'll discuss about factors affecting orientation sensitivity. And after that, I'll talk about recent advances and experimental findings related to this concept. And after that, I'll discuss about applications of this concept in optical communications and security. And after that, I'll conclude this topic and I'll tell about the future directions related to this topic. So firstly, let me introduce this topic of photonic crystal fibers, that is PCFs in its abbreviational form. PCFs are in general those kind of optical fibers which have a kind of periodic microstructured cladding within themselves, which improve their efficiency in a lot of ways, which is why they can be able to guide a lot of required light through the photonic band gap or the total internal reflection, which is modified as per the arrangement of atoms in that cladding. So hence this is the introduction I've given to you regarding this topic. And now I would like to tell about hexagonal lattice PCF's structure and properties. Hexagonal lattices designed with air holes in silica matrix are formed due to a lot of arrangements within the atoms. These kind of designs enable tunable dispersion, birefringence, mode confinement, and many more. Which is why this concept or this theory is used a lot in a lot of aspects such as non-linear optics, sensing, communications, and many more. Hence, this is the explanation I've given to you about hexagonal lattice PCFs, their structure and properties. Now let's discuss about fundamentals of orientation sensitivity. This concept of orientation sensitivity arises due to asymmetry in mode distribution, which happens a lot in a lot of atom arrangements in the concept of lattices. In a lot of scenarios, small angular variations impact birefringence, polarization properties, and many more, which manipulate the efficiency of the concept of PCFs. But this concept is a lot of importance having in the high precision for optical applications. Hence, this is the explanation I've given to you in the concept of fundamentals of orientation sensitivity. Now let's discuss about mode propagation in hexagonal PCFs. In this mode propagation, light propagates through core and it's guided by air hole lattice. This impacts the direction of light. Effective index of it changes with the orientation of lattice, which impacts the index a lot. Birefringence influences polarization and the polarization dependent loss and coupling and a lot of things like this. Hence, this is the explanation I would like to give you and I gave you about mode propagation in hexagonal PCFs. Now I would like to discuss about the factors affecting orientation sensitivity. Structural imperfections in it and fabrication tolerances regarding that occur a lot. Variation in the air hole diameter and spacing in between the arrangement of particles occurs a lot, which impacts in the existence of the substance. And external perturbations like bending, temperature, strain, and many more can occur due to that. Hence, these are the factors which affect orientation sensitivity a lot. Now, let's go to the next slide. Now, let's discuss about recent advances, experimental findings related to this concept. A lot of novel fabrication techniques which improve uniformity are happening due to this concept. Simulation models which predict the orientation development dispersion are getting advanced more and more due to this concept. And this concept has a lot of applications which are useful in polarization maintaining, tunable filters, and many more. Hence, this is the concept of recent advances and experimental findings which I have hence shared you. Now let's discuss about the applications of this concept in optical communications, sensing, and many more. A few of them include high birefringence PCFs for polarization maintaining systems, and after that, the another thing which is very impactful nowadays is that strain and temperature sensors based on orientations affecting many more. And after that, the final one which I would like to share you is that optical signal processing and non-linear fiber optics is being advanced today only and only due to this concept. Hence, this is the concept of applications in optical communications and sensing. And now finally let's conclude this topic and let's discuss about the future directions of this concept. This concept of orientation sensitivity plays a crucial role in the concept of hexagonal lattice PCFs. Advancements in fabrication and modeling improve performance. Future research regarding this concept focuses a lot on robust designs for sensing and communications. Hence, this is the conclusion of this topic finally. And hence, I would like to thank the respected professors who had given me this wonderful opportunity to speak upon this wonderful topic. Thank you.